Excellent. Great. Well, welcome everyone. This is the fourth session in our Embodied Carbon series, 4 out of 5. So the penultimate, and it's an event organised by the Sustainability Group. And we've got some other volunteers from the Sustainability Group this morning as well. We've got, I think we've got Will Mawson. I was online a second ago. We've got Jason Gibbons. Jason, give us a wave. Jason's actually in person at the Farrell Centre this morning. For those of you who don't know, this is a joint session with the RIBA Northeast Small Practice Group. So they're going to be having a series of events at the Farrell Centre today. So as you can see, we're recording this event. We're going to make it available online, and we'll share the link in our social media. I'm going to share our my slides in a minute. Let's just do this. Yeah. Yeah, can you see that slide, Mark? Does that look good?
Absolutely.
Excellent, great. So yeah, this is the Embodied Carbon mini-series. We've had 3 sessions so far. All of those are now on YouTube. So if you want to go and have a look at those, please do. The first one was an introduction to Embodied Carbon. So we were covering the basics about what it is and sort of some of the pitfalls and the challenges of dealing with embodied carbon. Episode 2 was very much about BIM integrations. We were looking at various plugins for Vectorworks and Revit. Session 3, which was actually last week, was a fascinating session. We had a couple of engineers. We had an MEP engineer and we had a structural engineer, both fantastic speakers. Emissions. So I recommend that. Well, I'd recommend all the sessions, but that one is also available on YouTube. Looking ahead to our final session, that's in 2 weeks' time. That's going to be looking at case studies, so very much embodied carbon calculation and practice. I'll say a bit more about that event right at the end, but essentially we've got 2 speakers. They are recent winners of the RIBA Northeast Awards. And they'll be talking through their projects and how they calculated embodied carbon on those projects. So we've got a big new build project, and we've got a small new build stroke conversion stroke retrofit project. So 2 very different projects, 2 different speakers, but both with sort of valuable insights into embodied carbon in practice. So today's session is focused on embodied carbon tools for smaller practices, very much about sort of lower price points in terms of purchasing the software, and hopefully a bit easier just to navigate, really. I mean, there's some fairly established embodied carbon tools out there, that perhaps larger practices use. I'm thinking of things like one-click LTA, for example. We've heard from speakers about that earlier in the series, but they come with quite a hefty, price tag or subscription cost. So yeah, this session very much aimed at smaller practices. Our speakers today are going to talk for about 20 minutes, and then we're going to have a Q&A session at the end. So please do leave your questions in the chat, and we'll pick those up at the end. And we are going to finish at 10:30, so no more than the hour. So don't worry about you'll be able to get back to your desks afterwards. So our 2 speakers joining us. Tom's an architect and he's a director at Studio Bark. He's spearheaded initiatives to develop in-house energy modeling, retrofit assessments, and lifecycle whole carbon accounting processes. Tom helped found ACAN, where he currently serves on the steering group. and also periodically gives talks and guest lectures on the intersection between architecture and climate activism. Tom's this morning, he's going to talk to us about SmallCarbon, which is a tool that's been developed by Studio Bark. And next up, after Tom, we're going to hear from Daniel Dyer. Daniel's an architect and a passive house designer. He's also an associate at Mawson Kerr Architects. Having moved recently to Leeds, Daniel's expanding Mawson Kerr's footprint so they can deliver more innovative, high-performance projects in Yorkshire. He also continues to support the team here. Just bear with me, please. Yeah, so he's continuing to support the team here in Newcastle as they scale up to larger housing schemes for developers seeking to bring the qualities from these homes to a wider market. Daniel this morning is going to be talking about how he uses the embodied carbon module on the AECB PHribbon, which is an Excel-based product. So, yeah, looking forward to hear what both speakers have to say this morning. Let's start with Tom. Tom, if you want to share your screen, take it away. We'll look forward to hearing what you've got to say on SmallCarbon.
Great stuff. Can you guys see that okay?
That looks great.
Yep. Great. Well, yeah, good to be here this morning, and yeah, thanks for the invite and intro, Adam. So I'm going to talk about SmallCarbon, which is a tool that we've developed over the past couple of years, specifically with the kind of needs of these in mind. So yeah, briefly to introduce ourselves, we are a small practice based in East London. We're currently around 15 people. Our sort of bread and butter, I suppose, is bespoke housing in the countryside, often using timber or other kind of natural materials. We also have something called U-Build, which is a kind of kit system. So it's a sort of modular self-build system designed for disassembly. So this is currently operating as a separate company. So I won't dwell on this for too long, but just to set the scene, I suppose, about why we're talking about carbon at all. I don't know if anyone's been to see the sort of national emergency briefing screenings. So there's currently sort of hundreds of screenings happening all over the country. I went to the weekend and very much recommend it. So yeah, this film is actually a really nice summary of a lot of the things that we all know, but it's put together in a sort of very concise form. So yeah, all of this is happening in the context of the imperative to decarbonize. And in the UK, we do have legally binding targets that we've set on that. And yeah, the government's watchdog has said that you know, the built environment is a really key sector to decarbonize if we're going to meet those targets. Lots of local authorities as well have set really ambitious decarbonisation targets. So yeah, the global picture, you know, embodied carbon is reckoned to be around 10 or 11% of total emissions. So it's not the lion's share, but it is a very significant chunk of global impact as well, like steel and concrete. So there's other perhaps easier to decarbonize aspects of the economy, like the power grid. As we make progress in those areas, embodied carbon is becoming more and more important for us to address. Just at a sort of building level, this is some data from Simon Sturgis, but yeah, if we look at the kind of balance of operational and embodied carbon is typically over half of total impact for the life cycle of a typical residential building. So it's really significant, something that we need to understand and kind of grapple with. Yeah, the things that are maybe driving this. So we have, practice's own kind of motivations and values and principles. There are also sort of industry initiatives architects declare. So one of the declaration points is kind of specifically on offering whole life carbon. Obviously got things like RIBA 2030, the new sort of net zero building standard, and the awards which lots of people came to us actually in the autumn last year because the RIBA are now sort of asking for these numbers. Another sort of driver might be clients. So this might be to do with the sort of their values or the way they want to kind of position themselves, or possibly for compliance reasons. In terms of compliance, a lot of local authorities are now requiring some kind of calculation, including the GLA here in London. So for particular threshold scale of on this. And so it's not kind of a regulated field at the moment in the UK, but it is regulated in other parts of the world. So you can sort of see this map of Europe, what other countries are sort of doing on that front. And in future, it may become regulated here. So it's sort of the imperative to kind of get to grips with it is certainly there. So in terms of SmallCarbon, why did we develop this? After we signed up to Architects Declare, we sort of felt the need to get to grips with this. Like a lot of practices, I suppose, we wrote our own sort of very complicated spreadsheets to do these calculations. And they look something like this. So we'd kind of draw up a bill of quantities, and then that would get inputted sort of line by line into this big spreadsheet. There was a lot of friction in that process. It was quite time consuming to do this, and there are often sort of errors creeping in that were difficult to identify. But it was a sort of useful process, and it was good in that we understood exactly what was going into those spreadsheets. It was not a kind of a black box, if you like. This is an example of the type of study we might have typically done through that process. So perhaps at stage 1 or stage 2, looking at some typical build-ups and just comparing the kind of impact of some of those material choices. So you can see the graph here on the right, the bar above the line in reddy orange is the sort of upfront carbon, and the green bar below the line is the sequestration within each of those build-ups for a sort of typical square meter. Other things, perhaps towards stage 3, we look at a whole sort of project, whole life carbon assessment, thinking about the project as a whole over its sort of nominal 60-year lifespan, and looking at different aspects of the building to sort of understand where the carbon is. So a sort of key trigger for us was the RICS updating their guidance in 2024, and this was good because they plugged a lot of gaps and a lot of sort of unknowns that had previously existed. So I suppose they're trying to make this realm of carbon calculation sort of more consistent and uniform, which is very much welcome. In the process of doing that, the calculation has become more complicated. So they've introduced a few additional modules and things like contingency factors, which weren't really there before. So alongside that, at a sort of similar time, we'd applied for some funding from Innovate UK to really develop our spreadsheet tool into something a bit more useful and usable. We collaborated with a developer called Looper, and also Etude, who are very good environmental engineers that some people may know of. So we were lucky to receive that funding from the Creative Catalyst Fund, and Yeah, the first thing we did really was to survey our peers in the industry and to try and understand what are the key challenges that other practices are facing. This quote on the screen really sort of summarizes a few of the key strands that came out of that exercise. So there was a kind of this tension of trying to undertake an early stage assessment when you don't know very much about the projects, the availability of data, and then also the fact that assessments can be quite complicated and time consuming to undertake. Last year we ran beta testing in the autumn. We had around 220 sort of sign-ups for that. And approximately half of the kind of practices who signed up at that point stated that they don't undertake any kind of carbon assessment currently. So we feel there's a sort of gap in the sector at the moment for people who are maybe interested, would like to undertake assessments or understand carbon and integrate it into their workflow, but maybe don't really have the tools or are not quite sure how to do that at the moment. So for now, SmallCarbon is very much focusing on the early stages. And you've probably seen versions of this graph in other presentations. And there's a bit of a tension because in the early stages, that's where you have the greatest scope to reduce your carbon impact, but it's also where you know the least about the project. So the tool is sort of trying to grapple with that paradox and help people to make lower carbon decisions. In terms of how it works, it's very simple. So it works on an area basis. So if you know the area of your floor and your walls and your roof, perhaps you get this from a SketchUp model, or you do an area takeoff from drawings, you can then apply a build up to that. So you can model. I'll show you the tool in a minute, and you can model standard build ups within the tool. You apply those things together and you get a bill of quantities, which is the sort of the basis for the calculation, really. So in terms of the aim, we want something really that was standalone. So in small practice land, we're all kind of using different softwares and workflows. We wanted it to be customizable so that people can really feel like what they've modeled in the tool is actually a good reflection of what they're intending to build or make. We certainly wanted it to be intuitive to overcome some of that friction that people are experiencing. Adam mentioned affordability at the start of the session. That's a key sort of goal. And then the last point sort of is maybe the overarching aim, which is really to sort of target smaller practices, which account for 80% of all practices, just in raw terms. So those are the kind of aims. I will. Can you? What are you seeing now? Do you see the tool?
Yeah, it looks like we're seeing a dashboard on it in the tool.
Okay, great. So SmallCarbon is a web app. So when you create an account, you can log in, and you have your individual sort of account. You also have an organization, which allows for sort of collaborative working across accounts. And there are essentially three kind of areas to the tool. So there's the library, which is broken into two subsections. So you've got materials and then also build-ups. And then there's the projects area. So just to dive into the library, this is really the kind of foundation of the tool. So within this, you have kind of different categories of material, different subcategories, and within each material, you can key data that particular material, so that there's sort of carbon factors, also some other useful physical properties, and some default assumptions about end-of-life scenarios and the carbon factors associated with those. So a lot of this data has come from the ICE database, which people are probably familiar with. We've tried to plug some of the gaps by creating our own sort of generic data points from an average of EPDs. So ICE doesn't have very much in the way of insulations. A lot of sort of more of the natural materials are kind of missing. So we've tried to sort of supplement the ICE database with with our own kind of library. I know that ICE are kind of currently reviewing everything and moving to a new model, so it's possible in future that we'll just be able to rely on their database. If you can't find a material that you need, there is the option to sort of add your own custom material. So if you've got access to a good EPD, for example, with the material you want to use, that can be input, and then that will appear in the library. So you can kind of see here some custom materials that some of my colleagues have added. The second area is the build-ups area. So briefly demo how this works. So you can create a new build-up, and then it's quite simple. You basically say what it is, what it's intended for. So let's try external wall. You can also add a few notes if you want. And then essentially you go line by line. So, if you were to model like a brick wall, just very simply, you kind of assign the sort of RICS category and give it a thickness. Let's add some insulation. So yeah, it's just a sort of process of going line by line. And yeah, you can also sort of change the kind of order of these layers. You can duplicate them as well. There's also a function to add what we've called child items. So if you have timber studs, for example, you might want to add a sort of softwood timber stud. You can specify what the sort of width of that is, and also the spacing. So then that'll kind of appear in the build up. So yeah, all the while you're kind of getting a real-time calculation of what the carbon impact for a typical square meter of that build-up is and how much carbon is sequestered. So yeah, once you're happy with the build-up, actually I do need to assign categories. And yeah, once you're kind of happy with it, you can click on create, and that will now be added to the library, and you can then call upon that and use it within projects. So the other sort of aspect of the tool is there is a compare function here. So you can use this to compare sort of materials. So, it's always a bit dangerous live demoing, isn't it? Yeah, so for example, insulations, let's say, if I wanted to get a sense of the relative performance of sort of insulations. So yeah, that's sort of quite interesting to get a comparative graph on a sort of per kilogram kind of basis. You can do the same thing with build-ups, and there's also a sort of function to compare different versions of projects. Maybe just before I sort of finish, I can quickly show you the project setup. So yeah, essentially fill in a short survey to set up a project, and you'll select what kind of typology it is, select the stage that you're at. Yeah, a few other details like anticipated year of completion and the sort of project context. There's some other information you might input like GIA. So just all the sort of basic kind of parameters of the building. You then have the option to input the kind of areas, or you can skip that and kind of come back to it later. And then there's a piece on operational energy. So it's not an energy modeling software. And if you want to include for the operational component, you have to have done some energy modeling somewhere else, like either dynamically or with PHPP, or yeah, had an energy assessor carry that out. So if you haven't done that, the tool won't sort of yeah, won't allow you to undertake the kind of operational carbon calculation. So yeah, the other thing you select is the kind of anticipated heat source. And then once you've done that, the project should be added. So you can see down here, that's been added to my list of projects. I don't currently have any kind of materials in here. So yeah, you'll see the kind of 4 tabs at the top. There's the overview that shows all that basic information that we've just added. There's then a quantities tab. So if I want to get some sort of results out of this, I need to add the quantities. So if I just try and add that build up that I made, so yeah, you can either measure the area from your model, or you can have the software sort of undertake that calculation. And yep, so here's, I can see from the drop down menu, here's the build up that I made just earlier. So I can click on that and add it to the project. It'll then recalculate, and it's sort of appearing now within my build ups. You might have some other elements that you want to add, like you might know that there's a certain amount of structural primary structure that's not really part of the build up that you want to add separately. So you can do that within the materials tab. There's also an allowances tab. So based on how you've answered the questions, like what the typology is, it will make some assumptions about MEP, and it will tell you what those assumptions are for each module. Oh, yeah. On so that's the quantities. You've then got a calculation tab, which is it basically deconstructs all of the build-ups and then sort of goes line by line per material to do the calculation across all those sort of life cycle modules. So this is the big scary table, and then the final tab is the kind of results. So you can look at upfront, embodied over life cycle, and operational. You can look at the total, or you can see it per meter squared, which is the sort of perhaps a more typical way of doing things. Yeah, further down, you've got a more granular look. If you wanted to kind of interrogate particular modules, you can get all those numbers and again sort them, or normalize them by floor area if you want to. There are some graphs as well at the bottom, so you can look at things in terms of the RICS categories, or in terms of NRM, or by building element. Yeah, so MEP is big. We've not really added very much to this project yet, so that makes sense. So yeah, that's the basics. The other thing you can do is kind of optioneering. So you can create different versions of the project. Yeah, and then you get some data about how those versions compare in terms of upfront and embodied, and you'll also get some graphs. This actually isn't a very good example, but it's the one I've clicked on. You can also select which benchmarks you'd like to look at and compare against. So yeah, just quickly to finish up. So in terms of where we are at the moment, we're sort of still in development. It's very much a work in progress beta. We are there's currently a call out for sponsors, so other practices who might like to be a part of the project and help fund it effectively. Yeah, we've currently got, I think, 8 or 9 sort of sponsor practices. We're going to be closing this sort of this sponsorship thing at the end of the month, at the end of June. Yeah, if you're interested in what we're doing, you'd like to keep in touch, then do follow us on the socials. There's also a specific mailing list for SmallCarbon. I can maybe paste this link into the chat after presentation. Yeah, that's it from me. Thank you.
Tom, thank you. That's fantastic. And I was frantically writing down questions as you were going through that, and then I think you've answered pretty much everything. So, but if people do have questions for Tom, please pop those in the chat, and we'll pick those up at the end. So let's move straight on to Daniel. Daniel, we've compressed your time. We've compressed your time a little, but we'll blame Tom for that. Please share your screen and carry on.
Right, can you see that?
It looks good.
Great. So I'm going to talk about the Passive House ribbon, which is, well, I found it earlier today. It exists in 2 formats. The format that I'm used to is that it exists within the PHPP, so it's an Excel-based add-in, and it allows you. It's kind of integrated into Excel, and it allows you to add carbon modeling onto your Passive House planning package Excel spreadsheet. So it can automatically pull information from your PHPP and use that, and then it's got an integrated database of the environmental product declarations, the EPDs, so that it's really useful, a bit of software particularly if you're already using a PHPP and you've measured all your build-ups, your U values, because it can take the information from that and reuse it. So I'm going to just talk briefly through one project that we use it on, which is a passive house that we completed in Warkworth a few years ago. And it's a timber frame passive house. It's still England's most northerly passive house. There's a few in Scotland, but we'll forget about those. But it's but I'm sure there's a few people in the room trying to build one further north in England. And it's a house for a retired vicar. She travelled the world a lot in her life and collected lots of things, so that the house became. It had lots of storage built into it, so she could have place for the things she'd collected. And then also, it was about the design of the house was about the place. It was about that area of Northumberland and also the views out to the coast. So it's an upside down house, bedrooms on the ground floor, living space above, surrounded around a little courtyard garden, and then views out to the east out of the big windows. And so the client was always very focused on a low energy, low carbon approach. She'd been kind of friends of the earth, which sounds quite old fashioned, but she was doing that since the 1960s, I believe. So she always wanted it to be sustainable. She wasn't too worried about passive house certification. It wasn't a focus of hers, but when we said we could get there, she was very happy to go along with it. So a lot of the materials are low carbons, local stone. There's a lot of timber. The main insulation in the wall build-up is cellulose, and there's a little bit of rock wool, and there is a bit of PIR and EPS in various sections, but relatively low carbon. It was built on one of these insulated raft foundations, which are relatively good carbon-wise because they create quite a thin slab and you don't have deep trenches of concrete everywhere. but that was kind of the main carbon cost on the project. So you can see that they're quite a thin layer of concrete, there's a bit of rebar in there, but it's, you know, it could be worse carbon wise. Then a lot of timber in the build up, and then we were pushing to get to passive house certifications. There's a bit of additional insulation that have gone in to get there. So yeah, relatively thin slab with the concrete, and then that got poured in, then you get the sole plate, and then from there you're very, very low carbon. Your timber frame goes on, which was insulated with cellulose, which is like recycled newspaper, so just fiber based. And you've got then the boards inside outside. You had eye studs in the frame. There's some idea of the build up there. So generally you've got quite a low carbon build up. And so when it came to wanting to measure this and explain this, we'd obviously already completed passive house information. So here's me very happy with the passive house certification. And those of you who've gone through it know that it's a very it's a process that includes a lot of measuring. I think Mark might have said this one, what you get measured gets managed, but it's quite an important thing when you think about passive house design, is that you're forced to measure your building and think about your building as a quantity, which comes in important when you think about carbon as well. So you'll have to measure the size of every wall, every roof, every floor. You'll have to measure every window. You start to consider things like form factor, so the efficiency of the external envelope to the internal envelope. You start to trade off those elements. So maybe planning or window positions or something aren't optimal, but you know they're important, so you stick with them. But you become aware of the numbers behind a building, which we don't want to completely dominate our way of designing, but it's helpful to be aware of. It's also helpful when you're trying to reduce costs and also think about carbon. You're thinking, how much stuff have we built? How big is this thing? How efficient is it? It's an important part of the design process to have a handle of how big is my building, what does it weigh, what's it made of. So you do these sort of things. These are just basic polygons you put over your model to measure the size of the thermal envelope, and this is all getting recorded in your PHribbon as numbers, basically. You're doing the same with windows. You're recording every window size. You're applying a frame to that, which is then calculating it's removing an area of glass from the edge and making that frame. So you've got the exact size of your glass, the exact size of your frames. Basically what I'm trying to say is there's a lot of information in your PHribbon about your model, and then when it comes to modeling the carbon, you don't have too much to add on, which is why the passive house ribbon is a really useful additional bit of software. But one way to think about it is when you model the PHribbon, you might exclude, or you do exclude, certain elements which aren't relevant to the thermal calculations. So we on this one generally excluded the outer leaf, which was acceptable to the certifier, and the cladding. So we just took it to the external wrap of the building in terms of all your U values and build-ups. But everything else within that thermal envelope is recorded in your U value calculation, which is what the PHribbon is able, sorry, the passive house ribbon, which calculates your carbon, is able to read from. So you're not just having a measurement of your wall, floor, roof sizes, you're also then applying to that all the wall build-ups. And when you add all that together, you've got most elements of your building. But yeah, so maybe if I was to say the building that I've actually recorded when I've measured it in PHribbon probably looks something like this, because I haven't included the external stonework and cladding in the model. I haven't included maybe the aluminium sills, they're not in the build-up, any steel canopies, any balustrades, they're not part of the thermal envelope, so they're not recorded. So those are the elements that you start to have to add in, things that finish off the building. So yeah, so this is I used it a few years ago. There's probably some updates for it, and Tom mentioned the 2024 RICS changes, which Passive House Ribbon has followed and updated to, so it is current with all of that. But basically what it's going to allow you to do, the embodied carbon calculator, is it's going to allow you to add your materials from your PHPP, then add your windows from it, then add your finishes. So that's then all the elements which aren't part of the thermal envelope, but obviously needed to be recorded to create a full picture of your building as an element in terms of carbon. So you add your finishes, your internal walls, intermediate floors, roof coverings, and then there's other things that can be added like the PVs, other materials. You can add them by weight or length. So here you've got an example here. So the PHribbon is reading from my U-value calculations, and then allows me to import them into the carbon model. Then you've got a similar thing with windows, and there'll be some manufacturer's data in here, which is really useful. So you're not having to get the data yourself. If the manufacturers have provided it, then it's going to be able to go straight into your model. And then additional elements of construction you're going to be adding in, and anything else. So including, important in carbon to measure air source heat pumps and ground source heat pumps, and the refrigerant that's present in those, and the life of the unit, because you're going to then have to dispose of that refrigerant and use it again. So Tom's talking about horrible tables. Here's the horrible table that comes out from the Passive House Ribbon. This is an example of the house we've just looked at. It helpfully highlights in reddy pink the worst offenders. So as you can see, that reinforced concrete slab was a big chunk of our carbon on this build. Then you've got windows. There was quite a lot of large format glazing. You've got the plastics in the insulations. A lot of it was natural, but there was some plastics insulations as well. So that's got some carbon cost. But then a lot of it is very low, and there's also a lot of sequestered carbon. So this may have been updated on the later versions, but we were able to pull out it works with lots of the different criteria for carbon. So LETI and RBA 2030 was noted on here, and it allows you to choose whether you're sequestering or not, and different standards have different ways of doing it. And I guess a really helpful thing to say is that I'm not like we're not regularly doing carbon calculations. Well, I guess we're doing them more often year by year, but it's not the day-to-day job of the practice. Like everyone else, I'm sure you're all very busy wearing lots of different hats. You're if you're doing passive house, you're working on reducing the heat demand and the general efficiency of the building. So having a bit of software like this that just goes that extra step to add on to the work that you're already doing is really helpful, because you've put so much effort into measuring and recording the building for the passive house process that it's useful to just have a little bit of extra process to be able to take that to carbon calculations that you're going to need to do it. So by these metrics, it's doing pretty well. It was hitting the 2030 targets. So we were pleased with those results, and it got an RBA award. I think it was 2 years ago in the Northeast, and obviously you had to submit carbon calculations for that. So that's a useful carrot for like focusing on having a process for recording carbon is that you're going to need it if you want to submit for RBA awards. And I guess one thing that the model helps us know about is that obviously timber is very good in terms of carbon. You can sequester carbon, and we work with the engineers so that this corner window is all made in timber. There's no steel cantilevers or anything, and I guess those sort of design decisions and being focused on finding the lower carbon solution is the reason why this house is relatively low carbon. So it's really important to work with the engineers and others to find those solutions that don't use steel. And there was really helpful talks last week. If we can find ways with foundations to do lower carbon solutions, potentially building with stone or other materials, that would be a way to further improve this. But yeah, I've gone through quite quickly, but hopefully that's enough for you. There's just to say there's other parts of the Passive House ribbon. I think Mark's made one of them, the daylighting part of it, and there's other parts that help make the Passive House ribbon more they help make the Passive House planning package more usable and just slightly improve the use of interface, and there's like libraries for U values and other things. So quite a useful bit of software. And I mean, if anyone's experienced with the standalone AECB calculator, which is related to the Passive House ribbon, that would be useful to hear about as well.
Daniel, thank you. That's really interesting. Please do put your questions in the chat, and I will pick those up. The first one the first question I had, and I know Daniel, you sort of reminded me there, because we obviously we've just had the RIBA Northeast Awards, and embodied carbon calculations is now a mandatory part of that, and our final session coming up in 2 weeks' time is going to be looking at how practices use that. Daniel, I know that the PHribbon is used for quite a lot of calculations. Often you see it referenced in RBA award entries, and I see it a lot in the likes of Passive House Plus magazine, where it seems to be the sort of the go-to product, I guess, because people are, the buildings in that magazine are typically using PHPP. But I was just wondering, Tom, you mentioned that your tool is geared up for early design stages, but could it be used to calculate embodied carbon for an RBA award entry?
Yes, yeah, it can be. It's in terms of the way we've developed it, we've focused on a kind of a stricter compliance with the RICS guidance for riba stages up to stage 3. So you can use it for sort of later stages, but it's not necessarily fully compliant with the guidance at the moment. That said, if we can get it working, and if there's sort of enough interest and uptake to sort of warrant us spending more time on it, then we would look to sort of develop the functionality of the calculation in the background so that it's sort of kind of suitable for all stages.
Yeah, absolutely. No, I think that'd be super interesting, and obviously, having seen the results of the RIBA awards, there's definitely a mix in the approach and the way some people are approaching how they're calculating embodied carbon. So there's obviously, there's no right way or wrong way. It's the same mechanics sitting behind it. It's just the sort of the different means in which you sort of attack the problem. Daniel, I was interested. It seems to me the difference between the two products I've looked at, Tom's very much focused on the ICE database, but the PHribbon has a huge amount of EPD information sat behind there. Did you find that useful in selecting the actual materials you were specifying, or did you have to introduce sort of custom materials, for example, the local stone?
I think there's a lot of, I think there is an ICE database within the Passive House ribbon as well. There's a lot of, I can't remember exactly the value I got for the local stone. It might have been a more generic value, which actually probably gave me a worse score than I could have got, because it was from just up the road. But yeah, you need a value that you can kind of know isn't too light, so you try and go slightly conservative on it. But no, I'd have to check. I think you probably do have to manually input some. You can manually input some information and look at EPDs and various other things if you have something missing. But there is quite a lot in there from memory. Yeah.
Yeah, it's always a case of, let's not let perfection push us down. We don't want to make it the enemy of the sort of progress. We need people to adopt this. So I'm not suggesting that we're going to the nth degree, but I think that's really interesting that it does have that sort of flexibility. And but Tom, there's a question coming from Will here, which I think is interesting, and perhaps one that's more suited to you answering, because Will says the models are fantastic moments. They're a sort of moment in time capture of the building's carbon on completion, but obviously buildings have a life beyond that point. I know it's early days for your software, but could you see a way that that embodied carbon calculation could be adopted by a client and taken forward to sort of record changes in the building over time? It's a big subject for 2 minutes.
Yeah, that's a very big question. I'm not sure. It's a very interesting thought. I mean, certainly one thing that we're interested to do is because it is an optioneering tool, it's designed to sort of sit alongside your design process and hopefully be intuitive and sort of productive enough not to be a burden, but be something that can be interesting and useful. So we would certainly like to look at across the project stages. If you've got a project and you do your first calculation in stage 1 or 2, how does that map against what you're doing in stage 3 and then 4 and possibly post completion? So that's not something that we've solved yet, but we are interested to look at that.
And Mark, you've raised a question in the chat there. Do you just want to unmute yourself and ask that question of our speakers?
It's less of a question, more of a comment, to be honest. Just that one of recognize. I'll read it really. The elephant in the room for embodied and life cycle carbon calculations is that they don't really consider resource efficiency. To consider resource efficiency, we also need to consider the kind of embodied energy, the primary energy considerations as well. Because as I've mentioned in another event here, that you could have something that's made using very low carbon energy, but use a vast quantity of it, and therefore that's kind of, it looks good on paper, but it's not necessarily good in practice. So we need, unfortunately, the ICE, as I understand it from the ICE database, has dumped everything that it used to do in terms of looking at primary energy, and it's now focused solely upon carbon. So it's kind of a bit of an own goal. So Tom, if you have any lobbying capacity, it would be, please can you reinstitute the primary energy one, because I'm sure it would bolt onto this information seamlessly, and then we'd actually have a more holistic way of looking at embodied carbon, life cycle energy use.
I think once you've decarbonised your energy, there is a whole new world of energy and carbon modelling. You're not really going to be interested in carbon at all if you have a decarbonised. You would then almost be back to like Buckminster Fuller, how efficient is your building type thinking, because everything is created renewably. So you need to use that renewable energy as efficiently as possible so that you can do more with less, I guess. But I don't disagree that it would be helpful to show both at this stage as well.
We've had a question in from Jason, who's unable to access the chat. Give us a wave, Jason. Jason's at the file center at the moment. But yeah, a really interesting question that Jason's raised was the sort of the pricing point. I know, Tom, you flagged up a slide there which looked like sponsorship pricing, but do you have I know it's not a product that's been launched yet, but do you have a feel for where how that pricing model will work once you launch it? Is it a subscription based? Is it a one-off payment?
Yeah, it's a good question. I can't really give a definitive answer because we're still sort of working it out. I think the feedback that we got, some people have quite a strong preference for like a pay per project model. Others are sort of happier with like a subscription we would like it to be affordable. So, you know, for perhaps a sole practitioner or a small practice, like 10, 20 quid a month, something like that. Perhaps for a medium practice, more like around the 50 mark. So those are the sort of ballpark numbers that we're sort of thinking of. But yeah, it's a bit of a balance between making it accessible and affordable. We'd obviously like there to be an income stream that we can then use to pay developers to improve it and keep it maintained and all that sort of thing. So still working that out really.
Yeah, brilliant. And that paper project model sounds really interesting, particularly for people who are interested in having a go, understanding what's possible. And with regards to the PHribbon, Mark has kindly popped the sort of the costs of all of those products in the chat. So look back and see those, but they're not crazy, definitely not crazy expensive, definitely very accessible to smaller practices. So I did say, you know, that we do have other comments in the chat. I did say we were going to finish at 10:30, so I'm going to draw it to a close and thank once again both our speakers, Tom and Daniel, for taking the time to prepare for this morning and to giving the presentation. Thanks everyone else for coming along. And as a final reminder, the final episode in this mini series is in 2 weeks' time, 2 weeks today, so that's the 24th. It's back to our normal time of 8:30 a.m. It's an online session, so it's a breakfast session, and we'll be looking at case studies of embodied carbon calculation and practice. So we'll have 2 speakers looking at how they actually calculated embodied carbon for their projects for the RBA awards, the recent RBA awards. They're both our speakers are award winners, so they must have done something right. So thanks everyone, and we'll look forward to seeing you then.
Yeah,
Thanks
very much. Cheers, guys.
Thank you.
Thanks, everyone.
Thanks, Daniel.
No problems.
Yeah, brilliant. Well, another good one, Adam. I think,
sorry, Mark. Sorry.
Another good one.
Another one.
Yeah.
No, that was really interesting. What a fantastic. The combination of both those speakers really really interesting. I'm gonna. Nick still works with you, doesn't he?
Yeah.
Yeah. So I was really interested to see that Tom shared the slide of the national emergency briefing, and that Nick raised that, because I actually saw that last week, and absolutely fantastic. And half of me wondered whether there's an event in the autumn themed around that, whether we have a perhaps at the Farrell Centre have a showing and then have a debate afterwards.
Yeah.
I don't know if you've seen it yet, but it's a really powerful movie and very. Obviously not just about architecture; it's quite a broad.
Sure.
Session, but I think it's there's something about it that's very powerful. Let's table that. I'll table that at the next
that'd
sort of monthly meeting.
Be a good theme.
Yeah.
You can then say how this is the context. How do we then apply that in our little corner of the world?
Yeah, absolutely. Yeah. Good call. Okay. Thanks, Ruben, as always. Thanks, Mark. We'll catch up soon.
Yep. Speak soon. Cheers.
Bye.
Thanks, Ruben.